motions. So there is another aspect of the kinematics, graph of motions. So here you'll be drawing velocity time graph, that's velocity against time, acceleration time graph, distance time graph. So when they tell me a particle starts from rest, so if this is rest, I'm starting here. A particle starts with an initial velocity of 4. So if this one happens to be meter per second, I'll be taking my 4 from here. This way, you understand? So let's look at this question and see how we go about it. A particle starts from rest and accelerates to a velocity of 5. The initial velocity, solution, the initial velocity is 5. And the time, okay, I'll come to that later. Okay, a particle starts from rest and accelerates to a velocity of 5 in 20 seconds. In 20 seconds, right? Good. So draw a velocity time graph. So that is a velocity against what? Time. That is time in seconds. Can you see that? There is velocity in meter per second. A particle starts from rest. This is rest. That's 0, right? So a particle starts from rest. This way, accelerates to a velocity of 5. So this can be the velocity, initial 5, right? Now, why is the unit to my velocity? It's on the axis. Are you okay? Good. Now, it maintains, so no, in 20 seconds. So the time it took is 20, right? I don't need to write a second. There's a second here already. It maintains this velocity for 10 seconds, right? So it maintains it for a further what? 10 seconds. So 10 plus this will give me 30, right? The distance between this and this is just 10. Agreed? Good. And decelerates to rest in a further 10 seconds. Doesn't mean decelerate, that's a negative of acceleration, right? If you are not accelerating, you are decelerating. So does it mean it decelerated by going back like changing everything to this point? No. This is our start line. Are you okay? So it decelerates to that start line once again. Look at it. Good. Decelerates to rest in a further 10 seconds. So this should be 40. Do you agree?
Yes.
Good. That is it. Now calculate the initial acceleration of the particle and the total distance covered. Good. Initial total distance covered. So what shape is this? It looks like a trapezium, right? What if you don't know that's a trapezium, or you don't know the area for calculating trapezium in mensuration? Now that is the best way to treat this question, right? Just divide them into sectors. It's very easy for you to get the area of a triangle, half base and height. There is a rectangle, length and breadth, half base and height. It's better. But to see some of parallel sides, then maybe you don't even know what we're talking about, right? So always, some of the shapes you can't even tell them well. So learn this method of dividing them into sectors, right? It's very easy. Now, calculate the initial acceleration of the particle. Good. So using v equals u plus at. So I want my initial acceleration, right? Good. So a car starts from rest. Oh, okay. There's a final velocity, right? There is a final velocity. The final velocity v is what? 5. We start from rest. So our initial is what? 0. U is 0, right? That is rest. Please take note. So this is 5 equals 0 plus a by t. The first time it took was 20 seconds, right? So you will ask, calculate the initial acceleration. Initial acceleration goes to an initial time. Are you okay? Good. That is 20. 5 equals 20a. That is 20 acceleration, right? So 5 over 20, what are you going to get? Yes. What are you going to get here? 0.25. 0.25 equals what? No, meter per second squared equals acceleration. So that is it. Now I've been asked to calculate the total distance covered, right? So let's go. Consider triangle A. Area of a triangle equals half by the base times the height. Now half. What is my base? Where is my base? Here. That's 20. Now what is my height? That is 5. So this will give me 50. You see, area should be in square units, millimeter square, right? I see our distance is in meter. I don't want to commit myself by writing a unit. You see, we are using the area approach to derive our unit. If not, I'll end up getting the distance by millimeter square. Fine, but I don't have a distance, right? So spare me that. Now consider rectangle B. Now area of a rectangle is length times what? Breadth. Now the length of this rectangle is what? 10. It's not 30, it's 10. Yeah, 9. It's 10. And the breadth is what? 5. So this is consider triangle C. Area is what? Half base times height. Half. What is the base? 10. Height. 5. You get one? 25, right? That's 25. 2 go here, 5. That's 25. Now, the total distance covered. Total distance equals A plus B plus C. Agree? 50, 50, 25. That is 125. Welcome to graph of motions. It's as easy as this, right? Good. I hope it's clear.